Guys, you took option number 2, so we're going to take a look at all of our problems based on the computer, not doing some of it in the real world. So let's take a look at the problems we started with. So it says, how many boxes can fit in the following shapes? All right, so now when we were taking a look at this, yesterday what you guys were supposed to do is you were figuring out the distance around a shape, which was the perimeter, and then you were figuring out how many flat squares fit inside of a shape, so like tiling a floor. All right, this is similar, but it's a little different. So what we've done now is we've taken a three-dimensional shape, meaning that it's got a length, a width, but it also has a height to it, okay, like most things in the real world. And what we're trying to do is we're trying to fill this box. We're trying to see how much it can hold. Now, we don't need to worry about the perimeter of it around the outside, but we do need to worry about the length and the width of it, okay? So it is similar to the area that we had been working with. The only difference, besides looking at just length and width, we've got this extra little bit going up, okay? So if you notice what we're measuring in this time, it's not squares, okay? I know on the outside you see a square here, but that's because each one of these is made up of cubes. Okay, so when we look at these cubes, we're going to use cubes to measure how much space is in an object. Okay, so the cube is similar to the square in that it has a length and a width that's the exact same size. All right, but the cube also has a height, which is the same size. So the sizes that we're going to use are 1 for everything. It's got a length of 1, a width of 1, and a height of 1. Now, in the real world, that 1 could be any measurement type. It could be inches, it could be feet, it could be centimeters, it could be whatever distance that we want. Same thing that we could have measured perimeter and area with. Now, the difference now, though, is what our term is at the end. When we measured around, so we were doing straight line sections, we were measuring the perimeter and we were doing it in just centimeters, inches. Okay, that was it. But when we measured the area, how many squares put in, we were measuring in square inches, square centimeters, square meters. So we told people that it had a length and a width by saying it was a square we were measuring with. Well, now we're measuring with cubes. So these are going to be cubic units. So cubic inches, cubic feet, etc. Now, we'll go over how to write that down in a little bit, but I just want you to remember, these are cubes, so they're cubic measurements. Now, this first shape that we have here, it shows some of the cubes that you would be able to see. It does not show all of the cubes, okay? Because it's a three-dimensional shape. I can't see the ones on the back side or the ones that are inside of it. You just have to assume how big it is and how many are in there based off of what we can see. So let's take a look at how to draw this out to help ourselves. So when we're looking at this, let's switch over to nice big red. All right, so I can count and I can look and I can say, well, it's 1, 2, 3, 4. It is 4 inches, and that could be long or wide. Okay, so we've got 4 inches or 4 cubes, however you want to look at it. Then going backwards, it's width 1, 2, 3, 4, 5. It's 5 that way. Now, if we were only doing area, I know that it's 4 by 5, so it's 20. So I would know right there, the area of this bottom part of it is 20 whatever, inches, centimeters, etc. But we have a height that we need to measure. Now, what I would stop and think about first, though, is I know that there's 20 squares that fit on the bottom of this, right? From the area, 4 by 5 array. So that means there are 20 of these cubes on this bottom section. All right? If there weren't, the ones in the back would be falling in and it would be caving all over. So I know that all the way underneath, like this very back one, there's some under it. So I know on the bottom section here that there are 20 cubes. All right? Well, there's 20 cubes here. That means there's going to be 20 cubes in this middle section too. And there's 20 cubes on this top section too. That means there's going to be 3 groups of 20. Okay, and 3 is the height right here. So when we're looking at it, that's our formula for volume. The volume of a shape, okay, the amount that we can fit inside of a three-dimensional shape, Okay, notice different from area. Area was flat. Volume is filling up a three-dimensional shape. It was the length times the width and then times the height. That's how we find the volume. Do not just sit and try and count all the squares you can see. That is not the volume. Okay, we're figuring out how many little cubic units are there. And to do that, we need to know the length, the width, and we need to know the height. All right, so if I was doing this first one, 5 times 4 times 3, me personally, I'd do the 5 times 4 is 20, and then 20 times 3, 2 times 3 is 6, so 20 times 3 is 60. So I would do that one. All right, so this really isn't that hard until all of a sudden we get to this one. Now, this is often how they will show you pictures for volume. Now, when they show it to you, okay, the purpose of this is you're not just counting the cubes that are there, it's just showing you the measurements, okay? So you can assume we're trying to figure out how many cubes could fit in it. So I could put plenty more. It only filled up one all the way to the top to help us figure out its overall height. All right, so what I would do is the same thing we did on the previous one. I'm going to look and see, all right, well, how long is it? So 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 units long, and it's 1, 2, 3, 4 units tall. Now, when I go to look at the height, the trick on this one is some people are just going to say it's 1, 2, 3, and they're going to say it's got a height of 3. Except look, this one right here is sitting on top of another one. Okay, we can't see the one it's sitting on top of. So I know that for this one, it's really one down here that we can't see, 2, 3, 4. So the height of it would be 4. So then all I do is I take these numbers that we just practiced, that we just learned, and I plug them into the formula, similar to what we did with area. Okay, all you need to do is you figure out what the basic measurements are, and then you apply it to the formula. So when I'm doing this, length times width times height, that means I'm doing 8 times 4 times 4. Okay, that's all I need to do with it. And then when I'm trying to do that, it doesn't really matter what order you do it in because you're multiplying all of them. So 4 times 4 is 16. And then if I'm doing 16 times 8, me personally, I'd probably break it apart and say that 10 times 8 is 80 and 6 times 8 is 48. And then I'd put the 80 and 48 together, which is, I believe, 128. I have been wrong once or twice before, though. So that's all there really is to volume. Okay, it's really just a matter of taking this new third dimension for our three-dimensional shapes. So we have a length and a width, and now we have a height. The height is what's going to be able to give us our volume, how high up we can stack things. So if we're filling the shapes now. So there's several problems on here to try. Some of them are going to have cubes filled all the way in like this, and some of them are going to be partially filled like this. On a partially full one, you are still figuring out what the total volume of the shape is. All right, so good luck. Remember, don't try and count them. It won't work. You need to use the formulas. Volume is equal to length times width times height. All right, so good luck. And if you have any troubles, stop off at office hours.